ஸ்டார்ட் பண்ணுங்க.
Hello, sir. Good evening. Can you hear me?
Yes, sir. Good evening, sir.
Yeah, just a minute. I will just. See my video.
Yeah, it came, sir. Then gone again.
It came. Now I think.
Yes, sir.
Okay.
Yeah. How are you, sir?
I'm fine. I'm fine, Mr. Mariappan. Yeah.
Yeah, yeah.
Yeah.
Your face, you remember me?
Yeah, I don't fully remember.
Ashok Kumar, no? Ashok Kumar. You are CAT alumni only, no, sir? You are?
Yes.
Yeah,
Right.
we spoke on that day.
Exactly.
So,
Yeah.
see, the Ashok Kumar and myself studied, but you are one set senior to us.
Yes. Annamalai and all your team, no? Ashok.
Yeah, Annamalai, Ramesh, they are all our batch.
Yeah.
Yes, sir.
Right, sir.
Yeah.
Okay.
So we'll start, sir. Yeah, 1 second, sir. How many? So we have about some 180 participants.
Oh,
Let me
okay.
check how many.
180
Yes, sir.
Okay.
So 30 only turned up. Anyway, we'll join, sir. They will subsequently join the meeting. We will start.
Okay. Yeah. Thank you.
I'll
share
Joyan,
my screen.
Yes, sir.
you formally welcome our speaker. Yeah.
Okay. Good evening, everyone present here. The next speaker for this workshop is Mr. Jayaprakash Gurusamy, who serves as Applications Engineering Manager at Train Technologies Private Limited in Bangalore. In this capacity, he plays a pivotal role in advancing heating, ventilation, air conditioning, and refrigeration technologies. Mr. Gurusamy is an active participant in the Bureau of Indian Standard, contributing his expertise to various technical committees. Additionally, he is involved in the MED03WG1 working group on semi-hermetic compressors and heat pump water heaters. His contribution to innovation are further evidenced by his co-invention as dehumidified air handling unit and desiccant wheel, for which he has granted US patent. We welcome you, sir.
Yeah,
You can
thank you.
start your session now.
Yes, sir. Now the floor is yours.
Thank you.
Yes.
I just have my screen, right? Yeah.
You have to share your screen, sir.
Can you share my? Can you see my screen now?
Screen is visible, sir. Yeah.
Is it visible? Screen is visible.
Yes, sir. You can go to presentation mode.
Okay.
Yes, sir.
Is
Fine.
this
Yeah.
fine? Okay.
Yes, sir.
So good evening to everyone. I think they introduced myself, Jay Prakash here from Train Technologies. I am actually over 25 years of experience in the refrigeration and air conditioning. Most of my experience, related to the refrigeration side on the commercial retail refrigeration as well as transport refrigeration. So today the topic on the food preservation case studies. Okay. Actually, just to make very clear, food preservation is one part, and the food preservation equipment that enabling the food preservation is the second part. So my background is predominantly from the food preservation equipment, actually case studies. Okay, so what type of equipment that enable the food preservation? So that's what. So with an introduction of food preservation, and we have some 3 case studies. So quickly we can go through that. I can summarize actually. Then we can take Q&R. So the first one is principles of food preservation. So when we talk about food preservation, there are 3 aspects of food preservation. One is we have to look into shelf life, and we have to look into food safety, and third is we have to look into food quality. In the food shelf life, we talk about food processing, food packaging, and food storage. As I mentioned, I predominantly come from the food storage, equipment manufacturing. And in the food safety, it is talking about like mostly related to chemical and biological, like retards microbial growth, eliminates microbes, destroys heat resistant spores. Okay, like fungus and all. That is on the food safety, mostly related to chemical and biological related. And food quality is about the end user, how end user receives the texture of the food has to be preserved. So normally when you store or preserve the food, the main thing is the texture may go, you will not get the same texture when you see the fresh food. And the nutritional value can go down if you're not preserving it properly. There can be a different order, or there can be change in the flavors also. So these are all some of the important parameters that we look into, like when it comes to food preservation. And in this food preservation also, there is some classification actually. Yeah. Yes, sir. Can you hear me?
No, sir. No, sir. Somebody have unmuted. Joel,
Okay.
please unmute them.
Okay. Can I go ahead?
You can go ahead, sir, please.
So we talked about the basic food preservation principles, but when it comes to the techniques, it can be still elaborated. The food preservation techniques, there are 2 major techniques in the food preservation. One is on the physical methods, another on the chemical methods. I did talked about on the food safety first actually. If you see the food shelf life, increasing the shelf life, you come to the physical methods. In the physical methods, there are like drying. By drying the food, we can protect, we can increase the shelf life. When I say drying means we dry many things, right? We fruits, vegetables. Nowadays, you get in the shop. We are going to see a case study on the drying also. Uh, uh, Many dry papaya, dry kiwi fruit, dry mangoes. You can get many things. Dry apples, apricot. You'll get many. Chilling means basically you see like all the horticulture crops we used to chill, like apple, oranges, skin of oranges. So a lot of that mainly related to refrigeration, or we call it as a low temperature effect to reduce the bacterial activation. We cannot remove the bacteria or microbes, but their activity will come down by chilling or freezing actually. Chilling. Freezing means very low temperature. Mostly it is less than 0 degrees Celsius. We store in a long term actually for freezing. Chilling is just not very long term, but we can even chilling like apples and all, we can do long term storage, but through a controlled atmosphere kind of process. Other fruits like banana or other fruits like other horticulture crop, like you can say onions or potatoes and all, even without controlled atmosphere, we can do it for a certain medium term to short term to medium term. Apple kind of thing, which is a seasonal, we can go up to 1 year using a controlled atmosphere. Freezing, as I mentioned, anything less than 0 degrees Celsius, and it can be like for example peas, seasonal product, green peas. We can freeze it. There are a lot of like pulses, grains, okay, green peas and many other things. We can actually freeze it and pack it and keep it. It can go for a long term. Canning is one method. Canning is like it is a very traditional old method. We used to can it, and maybe we can use some kind of chemical or some kind of packaging and do it airtight so that the canning will avoid, for example, the respiration. Suppose you take small mango, small type of citrus fruits, you can it properly and keep it away from the sunlight, it will not respirate it, the respiration will slow down actually, and that can extend the shelf life. So that is the process of canning. And in some of the method, the canning, they will add some kind of for example, below you can see that sugaring, right, or some kind of chemical. When I say chemical, natural can be, it can be very natural also. uh, like there's a kind of solutions available like osmotic solutions, so they can use that actually, and they can use it in the can and dip it, and it can go for a long shelf life. Smoking, it very obvious, especially smoking is used in the, like we know, like barbecue chicken and smoked meat, smoked fish. It can, they smoke it, only thing is that texture and odor and flavor will completely change, but yes, it can give a long term storage. It's a very old method of storage. Pasteurization, yes, milk, very famous. In the pasteurization, what we do is we immediately increase the heat, above, say water is 100 degrees, right, close to 100 plus 102, somewhere around that, and suddenly will cool down. So what happened, the microbes, bacteria will die actually. And there is very specifically, because milk is a very highly, it's a very short term. If you are not taking care of it, within 4 5 hours it will turn bad actually. So pasteurization is very important in the kind of a highly perishable liquid kind of food like milk. Salting, we know very much, similar to pickling. We add some of the spices and salt, we can use it. That also go for a long. And sugaring, finally, I was talking about some sugar solutions, right? Like for example, sugaring, or similarly like vinegar is the natural vinegar. We can use that, and we can dip some small fruits and berries, and that can go for a long time. So these are all like a very traditional method. Only thing is there can be aroma change, or there can be different taste, order. It will not give that original. But in my case study, I'm going to talk about only on the like drying, chilling, and freezing. The first three. Why? Because these first three, when I'm highlighting these first three, is going to be for mostly horticulture and meat and fish meat products. Those things are kind of a long-term mechanized physical methods. Of course, there are like salting, pickling, packaging, sugaring. That is a long-term. which is a chemical method, which is not my expertise. So I'll be talking about only these first three very specifically today. Okay. Any doubts on this? Can I proceed?
Yes, sir. You can proceed, sir. Yeah.
Okay. Thank you.
Yes. Yes.
I'm just checking in between. Okay. Just to keep
Yeah.
myself in line
Yeah.
with
Yes,
your.
sir. Yes, sir. We
Yeah.
are listening, sir. Yeah.
So we talked about food preservation techniques, and there's a very major classification according to the how we are avoiding the food, contamination and all. For example, there are three types of classification in the food preservation methods. Okay, one is called inhibition, another is called inactivation, another is called avoid recontamination. Okay, now what is inhibition? Inhibition is we cannot eliminate the microbes, bacteria inside, but we can reduce their activity. A bacteria, like the growth of the bacteria. If, for example, I mentioned about the fruits and vegetables, it is slowly rotten, right? So that is because the bacteria activity is there. But if the why? Because the temperature is in the ambient temperature. So when the temperature is, for example, above 15 degree, 20 degree, 30 degree, close to that range, the bacterial colonies production will be multiplying in exponential manner. So when it multiplies exponential manner, it will totally spoil the food. But we cannot avoid the bacteria. So what we can do is we can reduce the growth of that, the multiplication of those bacterial activity. So that is called inhibition. Okay. So what to do? So now we reduce the temperature. Apple is there, or any orange or any banana is there. So you leave it, it will ripen, rotten, and bacterial activity will be there. Now you reduce the temperature. So the colonization of bacteria will come down very rapidly, but still some bacteria will be there. You can live with that actually. So low temperature storage, we can do that. That is inhibition. Then second, reduction of water activity. What do you mean by reduction of water activity? For example, drying. Okay, if you remove completely moisture, water from the, say, fruits and vegetables, you can actually, because water is one of the important parameter where it will enable the bacteria to grow faster. So if you remove the moisture, more moisture, it become dry, tissues, everything, texture, everything, but we can remove it. There actually we can avoid the bacterial growth. Decrease of oxygen, very important, especially like long-term horticulture crops like apples and oranges, where we are storing. We have only one season available. We put it in the big cold storage room or a container. What will happen? The fruits and vegetables, even after harvesting, they keep breathing. When I say breathing, respiration. So they involve, okay, they intake oxygen and they give out CO2. So now what to do? Now we have to reduce our air, atmospheric air is having 21% of oxygen. So you put apple inside the cold room, you just leave it and keep it to lower the temperature, bring the temperature down to 2 degrees Celsius. But that is not enough. The apple will, consume the oxygen and it will become ripe. It will go on ripening stage actually. So what we do, we have to remove the oxygen. We call it as a controlled atmosphere. So we give more nitrogen and very, very less oxygen, maybe 1% much lesser, so that we can say like it will go into a coma stage, right? And it will be like that only, almost close to dead, but it is not dead. Okay. So that it will not age. So it will be as it is actually. So you can take it after 6 months or 10 months. So that's called decrease of oxygen. Increase of carbon dioxide also is there. This is another method actually. Then acidification, fermentation, these are all adding preservatives. These are all the chemical methods. And freezing, yes, we can do blast freezing. Quickly we can freeze to avoid any, especially on the meat products like fish and other things. And drying on the horticulture crops to remove the water activity. Now I have just made a round actually here, some circle, because these are the areas I am into that, and today I'll be talking about the case study on the low temperature storage, reducing water activity, and freezing and drying. These are the three I'm going to talk. In the inactivation, where inactivation completely to remove the microbes, okay, not reducing but removing. So we use sterilization, pasteurization, specifically in the milk products, dairy industry. Irradiation means like UV light. Use a UV light and do irradiation. So UV light will go and attack the DNA of that microbe, and it will destroy. So electrifying, pressure treatment, high pressure, blanching. Blanching means like temperature, increasing the temperature. Cooking also higher temperature. Frying, extrusion, light. Some kind of light is not good for some of the microbes. Sound means vibration, sound and magnetic field. So this all we are using this kind of techniques to completely destroy the microbes. And the third one is the avoid recontamination. So after harvesting or after getting the uh, goods, freshly harvested foods, whether it can be vegetables, fruits, or it can be meat and meat products, how we can extend shelf life? Immediately, what we can do is we can be a good packaging. When you do processing for packaging, you have to do hygienic processing, then hygienic storage, including the low temperature storage or pasteurization, inactivation method. And we also have to follow some of the standards like ISO 9000, TQM, HACCP, and the risk analysis and management. So this kind of process you have to follow to avoid the recontamination. So you got it from the harvesting, then post harvesting, what you have to do. That is the main point here we are talking about. So this is on the classification. So next is factors affecting the food quality, safety, and choice. This is a kind of a flow chart where the quality, safety, choice, whichever is the call. Sorry. So whichever how the customers receive the quality of the food and how they select the food based on what. So this is what it is explaining on that. These are the three main criteria on that actually. For example, choice, if you say, the choice can be from different perspective of a customer who wants to take food, like sensory, nutritive, functional, or convenience, or that is one way. And another way, through advertisement, public knowledge, through social factor, like economic, cultural aspect. So everything will be there actually. Okay, now what are the causes of food deterioration? So I just talked about, there are basically 8 types actually. One is on the gain or loss of moisture. Yeah, if the water gain and loss of moisture, then there is a food deterioration. Reacting with oxygen or light. As I mentioned, the more respiration with oxygen or light. So there are some other foods you have to, especially in the canning or bottling, it's not a white bottle, it will be a black color bottle. So the light also will actually affect the deterioration. Time, more time, it will faster deterioration. Physical stress or abuse, inappropriate temperatures. Every fruits, see, and also one thing I want to mention here is not all the fruits and vegetables or meat and meat products have the same temperature of shelf life storage temperature. Even apple is 2 degree, but banana is 15 degree. So that's the difference. Onion is somewhere 7 to 8 degree. So this is the kind of temperatures you need to, not everybody is same temperature. Infestation by insects, parasites, and rodents, you have to keep them away. That also will cause deterioration. Food enzymes and other chemical reactions within the food itself. It is maybe some of the chemical contamination. They will activate the enzymes actually. Then of course these are major microorganisms, bacteria, yeast, and molds, and this is where we use inhibition method, inactivation method, what I talked about earlier. Okay, so these are the basics of the food preservation. So next, let us come to the various stages of food production, storage, and distribution. Yeah, I'm going to talk about, this is on the, when a kind of a chart from the APIDA and also from the NCCD, National Center for Cold Chain, okay. There is a, whenever we go for a horticulture crop, we want to follow a certain process, right? For example, you would have heard some of the terms like farm to fork. So farm to fork, it is a kind of a chain. So here you can see here harvesting, storage, processing, packaging, storage, distribution. Then it go to sale. Then from once again to transport, storage, and consumption. Now harvesting is the farm, and the consumption is the fork. So farm to fork, we need to maintain certain storage parameters, right? Now, for example, processing and packaging, we need to very cleanly we have to handle, like contamination. We talked about that contamination, right? That we have to follow packaging, hydrocooling, cleaning properly, or blanching. So these kind of things we have to do during the processing in the initial post-harvesting technologies. And after that, we have to storage, pre-cool it. Then we have to bring down to the low temperature. Then in the transport, we have to use a reefer truck container so that the food will be stored at a lower temperature to avoid the inhibitions like bacteria, reduce the microbial activity, and then storage into the supermarket or cold rooms, and it for a long-term storage. So this is called farm to fork, and in that the preparation, transit, shelf life. So all the things are completely it get involved in food preservation stages, whether it's a preconditioning pack house or transport, refrigeration or a cold store, or get into the retail store or kitchen shelf. Or kitchen means refrigerator inside your kitchen. Everything comes under food preservation stages actually. Okay, now, so quickly I will go through three cases. One is the case one, extending shelf life by low temperature cold chain by Apida, that is for a banana export to Dubai. The case 2 is extending shelf life by freeze drying, Ice Make India. The case 3 is extending shelf life by food dehydrated E3 Agro Solutions. These are the three enterprises I just took. There are some other things directly customer's name we may not mention, but I just going to talk about more about the technology here instead of talking about which customer, what and at all, because of some other reasons. Okay. Okay. Now, the low temperature storage cold chain, we talk about farm to fork food chain. This is a high level source from NCCD. This is a standard guide. If you go to NCCD website, you can actually, there are some manuals and guidelines. Not only that, even in National Horticulture Board, you can actually download the design aspects of cold chain or the equipment design or the equipment, for example, the details of complete configurations of a cold room or cold storage. This we can get to know actually. And now we also talked about why the cold chain low temperatures, right? There is a small graph here. Okay, the effect of lowering temperature on shelf life of perishables. Say for example, different fruits: raspberry, strawberry, mushroom, green onion. Now the temperature say 20 degree, right? Now 20 degree for say mushroom. So only how many days? 5 days, right? But if I reduce to 5 degree temperature, it will go around some close to 8 days. So that's how, as you lower the temperature, the shelf life days of these horticulture crops will increase actually. So this becomes a very important part of maintaining a cold chain here. Okay, now the banana export APIDA report, the process of exporting quality Nendran banana to Dubai. How this is, what are the process they are doing it in this preservation, and also there is some kind of ripening, banana ripening, which I talk about also here. First is harvesting, then cleaning with chlorine water, then rinsing with water and trimming of crowns. So these are all part of food preservation, but post harvesting. Then delatexing of hands actually means that hands means the different you call like from the bunch of the banana you remove one by one. That hands I'm talking one bunch will have like 10 or 20. Fungicides and alarm some kind of fumigation. Fungicide means like a kind of a smoke or some kind of fumigation fumigation treatment they will do, and they will do the grading and sorting and packaging. So till this time it will be a lot of human activity will be there, and after that it will go into the storage and ripening, and from there it will go to marketing and consumer. So this is a complete cold storage, and we can extend the shelf life by following this process meticulously as per the guidelines, whatever recommended in APIDA. APIDA means Agriculture and Processed Food Export Development Authority from the central government. There are a lot of schemes and a lot of guidelines available for food preservation for both horticulture and meat products, where you can refer actually. Okay. Now the cold chain banana export APIDA report. Okay. What are the process? I'm just giving more house hygiene. Minimizes the pest and diseases because these are pre-storage. Keeping the packing area clean and free of trash and banana debris. Hang bunches overnight. Allows fruit to cool, reach uniform temperature before dehanding, grading, washing and packing. Then careful dehanding when you are removing out of the bunch, right? When you're cutting, you can see the last figure of these doing. minimizes rot of curtains, use sharp, clean knife. Yeah, that is important, clean knife. Otherwise, it may be it will contaminate and make even cuts. Then washing. Washing is a very, very important point where you can actually remove some of the harmful, microbes also. Removes sap stains, superficial insects and fungi. Water soap 0.5 to 1% bleach. Then drying. So after that, you cannot leave just like that because the water can once again contaminate sudden because of the atmospheric conditions. So you have to do an air drying after wash allows dry fruits to be packed. Okay, so by doing this, there's a less chance of fungal attack actually. Also, it will not attract some insects at all. Then packaging, well ventilated boxes you have to package, careful placement of bunches, use of plastic liner, and storage shipping depends on market and ripening process. Okay, now this is on the how we need to as a case study of how banana is treated before even going for a cold storage. Now, when it goes to cold storage, there are two types of kind of commercial ripening we call. Once you put, the banana will start getting ripening. Either we can hold it for some time, or we can, by the time it reaches to the customer, we can actually do it for ripening. It will take like 2 to 3 days, or more than that, 4 days it will take. Depends upon how you do a ethylene treatment or how you are controlling the temperature. So commercial ripening assures good shelf life, provides excellent fruit appearance, provides optimum eating quality. Fruit is available when and where required actually. This is called ethylene generator actually. Okay, now ethylene naturally produced by fruits actually, but we want to do activate and keep the ethylene concentration uniform actually. Uniform at uniform temperature, normal relative humidity, all the parameters when we are controlling, then we can get uniform ripening, and by the time it reaches customer's place, it will be ready for eating actually. And it will be good color, good quality. Even the taste and flavor and odor will not be any problem actually. For example, some of the 4 major factor in this is ethylene gas. It is start with 1 ppm only when the starting of impingement. It can go up to 1000 ppm, depends upon the requirement, and up to 24 hours. Temperature control is 14 to 17 degrees Celsius on banana. Banana is a kind of a tropical crop, and because the tissue is very much susceptible to the freezing injury. If you have banana less than 12 degree, less than say 12 degree, it can easily get into chilling injury. Chilling injury means very cold temperature. The tissue will get cold impact actually. That's why banana you will see never you will not keep into your home refrigerator, right? You can keep your apple or any other fruits and at all, or even vegetables like carrot. But banana will never keep in our refrigerator because the average trade temperature will be around 7 to 8 degrees Celsius. It will chilling injury will be there. So relative humidity control should be 90% organs, adequate air circulation, exhaust CO2 based on ppm levels actually. Small banana ripening chamber, not much CO2 sensors will be there because there will be a automatically sometime they will open once in a day at least minimum. So that will take care of that CO2. But in a larger banana chamber, they will be having a CO2 based controller. So based on the ppm, for example, say for example 800 ppm or 600 ppm, they keep it, and accordingly based on that there will be an exhaust ventilator, and it will remove the CO2. So you can see the day 1 to day 7 how it is changed. Very raw, but ready to matured raw stage. Then day 2, day 3. By the time it reaches the customer place, it will either you can store it here, or even this particular project Apida, they put this in the container, include ethylene fumigation, everything. Then they sent it over the, and by the time they reach, they will get ripened. They will sell it in the market. So this is the banana ripening detail actually, process of banana ripening. So as I mentioned, banana ripening is also engineered to stimulate natural ripening process by temperature control, exposure to uniform and controlled ppm of ethylene gas, venting of CO2, and reducing total ripening. Process of 4 to 6 days for best quality. The room must be airtight to prevent too much of ethylene from leaking out. Room must have adequate refrigeration, proper temperature, and room must have adequate air circulation. And also it should be stacked in the crates, proper crates. and maintain proper humidity level actually. And also ventilation has to be taken care by opening the doors for every 20 minutes, for every 12 hours or 24 hours of ripening. So what are the requirements? Major component for ripening chambers as a equipment in the refrigeration equipment. These are some of the major component we use in banana. Puff insulated chamber, insulated doors. Puff insulated chamber is like nothing but this one. These are puff insulated chamber and equipment and doors. Okay. And the refrigeration system with higher airflow evaporator. This is a refrigeration system with the higher airflow evaporator. Control panel, humidifier. There can be some humidifier also. And ethylene generator CO2 and ethylene analyzers. These are exhaust, and great for stacking. And yeah, ethylene analyzer to monitor levels of gas in the room actually. There is one a case. This particular case study by APIDA report, they have given the details of what is the specification of that banana storage chamber, and also how they are processing the complete from the harvest till their storage, and the reefer van till you can see a reefer van starting from fiber tank for washing the banana. Okay, what all the equipments are required? Plastic crates, polythene bags, foam seats, vacuum sealer, air remover for sealing it, ethylene absorber, rubber. Until cold storage unit, they are storing there in the site. Then reefer van, the reefer van will export, go to the port, and it will be taken to the in the ship and they export to the Dubai. So this particular project is preservation of this banana and sending it to Dubai by the APIDA by the help of it. So this is the how overall APIDA came up with this. They started some of the pictures from the field actually. Cutting the banana, cutting out the hands actually, and treating, washing it. Okay, then grading it, then going to the storage. I have not put it because multiple images I shown. Then after going there, this is the final place where this is a supermarket in Dubai. So this is how they sell it actually. This is one of the successful case study. The report is also available in the APIDA. You can go and download for the detailed study. And if you want to really, there are also like some of the reports in banana ripening chamber, subsidy schemes, and different, what all the more technically complete parameters, details, a detailed report out, everything is available in NHP, National Horticulture Board website, NCCD, as well as the APIDA report actually. You can do that. And I want to thank from APIDA because last time in our history RefCon team, the APIDA chairman has sent their delegate to present one of the case study on the meat processing industry. That also you can actually look into that. So in fact, I requested them to provide some of these documents for this particular presentation. And thanks for the APIDA. Yeah. Sir, any queries? I'll go to this case study too.
Yeah, participants, if you have any questions, you can interact. Sir, actually, that ethylene, is it ppm? You told 1000 ppm.
No,
so
mm,
you have given some, from 1 ppm to 1000 ppm.
yeah.
So what
Yes.
will happen if it is more than 1000 or any? What is the effect of
The
more,
ripening will be much faster, and the order will change. And
okay.
also another important thing, ethylene more than 1000 ppm will be not only not more than 1000. It is more than 20,000. I think more than 10,000 ppm only. It is highly flammable. Flammable means safety issue. Yeah.
Safety issues will come.
Yes.
Okay.
And anyway, the order only will tell you cannot enter actually more than 1000 ppm.
Okay.
It will smell also. Yeah.
Mm. And also this relative humidity maintenance, you will be having a
Yes. We have a
this one
humidifier.
moisture, a
We
humidifier
can
will be
use,
there.
yes.
Yeah. If,
I would recommend use this ultrasonic humidifier. Okay.
okay, sir.
Because earlier, no, we use steam humidifier. Boil the water.
Okay.
That also will add some heat also. Boiling the water.
Yes.
And
Yes.
Nowadays, we have very excellent ultrasonic humidifier.
Humidifiers
Even
are
in
there.
during
Yes.
Corona time, many people are using ultrasonic humidifier
Yes.
at their
Yes.
home
Yes. Sir.
actually.
Yeah.
And it will, cold water only, it will make it very fine mist, and we can maintain
Yeah.
at 90%. There are a lot of very good local Indian
Okay.
manufacturers out there 90 for ultrasonic
Okay.
humidifier. It is costly, but it is very uniform.
Mm.
You can closely plus or minus 3% with your sensors, with the highly precision sensors. You can maintain plus or minus 3% average with ultrasonic humidifier. Yeah.
Sir. Yes, sir. So one more question from participant: is there any
Yeah.
alternative to ethylene? That was his
Okay.
question.
Okay. So
Mm.
see, alternate, if you go and when I mentioned about this National Horticulture Board, in their document, they mention alternative way. There is some other chemical. They also mention one caution that there is a calcium carbide, right? Which people use in developing countries, or so that
Yes. Yes.
actually they are telling it is very, very, not good for health actually.
It's good
It
for
has some
health. Yes.
carcinogenic material. Okay,
Yeah. Mm.
that's why.
Yes, sir. Yes, sir.
Okay,
I
yeah,
think we'll go to the next case study, sir.
yes,
Yes.
yes.
Thank you.
See, even if banana, traditionally in India, they use like rice paddy, rice paddy, that husk and at all, right? Once you harvest the rice paddy and at all, so they use it and put in, they put some agarbatti and at all. But what will happen is there is no there is only one. Automatically, what they just sprinkle some water, the ethylene gas will generate slowly, but you don't have control on microbes. So you see like a lot of black dots on the banana, the traditional method. Even though if it is ripening, it will be tasty, but it will be black dot. But actually, this way you control humidity, temperature, airflow, and ethylene concentration. You see the banana is purely like greenish golden color. Very nicely it will come out. You can see in supermarket here. Okay, now next is the freeze drying. Okay, these are very different, but it's one of the costliest method. But it's a technology actually. Why it is freeze drying? See, there are some very uh, costly fruits, or costly even pharma, some milk products. Just one information recently, like in the same company, this is a company called IceMake. Okay, I visited there actually, and if you see the cow milk, okay, the new cow milk means when the cow give the birth to the calf, the first milk will come out. That milk is only one time available, right? I'm just giving an example. And that milk you cannot store it actually, even with pasture, whatever, you cannot store. But if you do these are very, very classical example. You can do a freeze drying. So freeze drying means you reduce the temperature at the vacuum level. Okay, like you can see that cylinder, big cylinder is a vacuum cylinder, and tray is there, but reduce the temperature up to minus 30 to minus 40, and reduce the pressure also, almost like close to vacuum. So what will happen as the pressure reduces down and down and going to minus 30, minus 40, the water will reach a triple point temperature, right? When I say triple point temperature, the water, the ice, it will form ice, right? The water will become ice, but that ice will not convert into water. That ice will directly go into vapor, which is called sublimation. So that is the process we are trying to do with the water. The water is going to be sublimated and removed from the product, and that product will become fine. For example, you can see fresh cheese, fresh dried cheese. It will be like this. But the taste, the texture, everything will be the only thing that moist water will not be there, but almost everything. I really tasted that. And another thing, you can keep it for even 10 years, 15 years also. It will not get spoiled. So that is the technology, but it's very energy intensive and very costly technology. Very important pharma products, very important food product, costly one. We can actually use this technology. This is one of the highly reliable, and the self-life, the longest self-life in the food preservation. This freeze drying is one of that actually. Longest self-life, we can do it. Okay, so as I mentioned, the vapor pressure diagram, water vapor pressure, liquid, solid, and vapor, right? Gas. So this is called triple point. Okay. And the triple, as you reduce the pressure, what happens? The water solid, it will come. Okay. The water will become ice. And after this, what will happen? The water, even if you increase the temperature, if you take that material out, the ice on the material will directly sublimate, become gas, water vapor. It will become water vapor and escape. And that product will be free of water actually. For example, it was boiling point water at precisely 100 degrees Celsius, right? And at low pressure, boiling point is reduced. If the pressure is higher than 6.1 millibar, okay, water passes through all three states. Okay. As the temperature increases or decreases, okay. Below this point, below the 6.1 millibar, if the pressure is less than that 6.1, it passes directly from solid to gaseous state, so that it will not get into liquid mode. What will happen if it get to liquid mode? The liquid once again will get into the solid, dry solid party. For example, the milk, the cheese. Milk and cheese is having dry solid material, or any fruit is having a dry solid material plus water. So after it becomes ice, the water will become ice, and that ice once again, if it become liquid, the liquid once again will contaminate and it will change its characteristics. So it will actually, all the ice will go back as a vapor, and it will leave very dry product, maybe less than 3 or 2% moisture only will be available in bone moisture in that particular product actually. It's all freeze drying process occurs below 6 millibar in regular practice. It may be below 1 millibar also. So this is the current technology available, and some of the manufacturers I talked about ice make, they are actually selling this. I just want to acknowledge I'm not selling that, but I'm just getting a case study from them and to showcase here. Okay. So this is the freeze drying mechanism. This is a freeze dryer chamber. Okay. And this freeze dryer chamber. Okay. The tray and everything.
Sir, one second, please. Dr. Ujjwala. Joel, just mute him, sir.
Yes, sir.
Yeah, please mute. Ujjwala is in. Yeah, please mute. Yeah. Sir, you can continue. Sorry for the disturbance. Yeah. Joel, I think you muted sir mic.
Oh.
Sir, one second. Sir, you can unmute yourself, sir. Mistakenly, he has muted your mic.
Sorry, sir.
Okay, someone muted me. Sorry.
Sorry.
Can you see my screen now? Yeah. Can you hear me?
Yes, sir. Yeah.
Okay. So this is a vacuum pump will once the product can be it will now what are the stages in freeze drying? You can see the process flow chart. The materials freezer normally what they do, they have the tray, movable tray with the wheels, put it in the blast freezer. Once it's subjected to -20 to -30, they just pull it out and push it to this vacuum chamber. big vacuum, the cylinder vacuum chamber for drying, and they close it, and immediately they will less than 6 millibar. Then the final products of moisture will till it will become, and the heating cycle everything will come till it become almost 3% moisture. They will do it. Once it becomes less than 3 to 4, 5%, then they will open and unload the batch. Then packing and storage. So this is how so this is the advantages of the and the fresh dragon fruit, freeze dried dragon, how it is. The taste will. I told that. Kiwi fruit. Texture and all, nothing will be the same. Taste is same. Instant rehydration ratio. That's why you can remove this like kiwi, then dip it in water before you will become like original. But the taste will be same. It can plus years without losing taste or nutrition value. Without excessive heating of product. So we are not heating the product. Chemical decompose is minimized. We are going to minus 40 degrees Celsius. All the almost zero is latest other than
sir,
the
excuse me, sir, your voice is breaking, sir.
Voice is breaking.
Yeah, yes, sir.
Yeah. Can you hear me now? I'm a little bit closer now. Is this okay?
Yes, sir. Actually, you can switch off your videos so that the bandwidth will be better, I think.
Oh, okay. I thought I'll. Is it okay now? Can you hear me?
Yes, sir. Yes, sir. Now it's better, sir.
Okay. Yeah. Let me go ahead. Yeah. Can you see my screen now?
Yes, sir. Yes, sir. Yes, sir.
Okay. So this is the case studies too on the freeze drying. If you need any more information, you can reach out to me. There are a lot of technical details involved. So given the time perspective, I just given the highlights only on this. But there's a lot of things to learn on this actually. This particular type of food preservation technology. The case study 3 is very simple. Everybody we know, we always get everywhere in the market, but it's a different type of technology. Earlier it's like hot air from the furnace, from many other places. This one of them is traditionally they're using this food dehydrator or food drying for papaya like this, right? So there is one project, one case study. Yes, they are also drying like spices, cardamom and all. But that cardamom, the important part of cardamom is it should the color should be maintained. Okay, now one important point here. Previous one is freeze drying. At all low temperature, freeze drying, the color also will not change. What color you give, the same color will be there. But in this hot air drying, there are possibilities the color can be changing if you are not controlling the humidity, temperature, and the time frame. If you are not doing that properly, and also this kind of fruits like kiwi and papaya and guava, mango, all these things, before even drying, they used to do an osmotic, kind of a sugar dip. Actually, they put it in a kind of solution where we can see in the horticulture and agricultural place, the research place, they used to do this actually. They used to dip there, soak it for some hours, take it out, then little bit dry, then they put it in the dryer. Then it will dry it. So that what will happen, it will not lose the taste, the nutrition values, and the texture also will not change. It will be intact actually. So that's how they does it. But this particular is for cardamom. So one of the place that this will protect the normal traditional food dehydrator. The color of the cardamom green will completely Sometimes it will change, it will become like yellow or light yellow, pale yellow, even white also, and it will not useful, completely damage the tissue. So this is a cardamom growing place in Kerala, one of the places. So green cardamom from the cardamom plant, it will be like this with a lot of moisture, with 95%, sorry, with 90% of moisture will be there. A traditional method of using a wood furnace they used to. Normally you store this cardamom, in another 1 week it will get, it will not, it using the wood furnace, and they will dry it actually. But what it came up is, see, these are key drying parameters: initial moisture 83-87%, final moisture, drying time, batch drying, color fresh green with good aroma, expected weight, drying ratio good, and temperature 45. Many like any fruits, like we talk about a lot of fruits in the earlier picture. Most of the fruits drying you see here in shop, they are subject to 45 degree. In fact, the same case study we also did for moringa leaf, right? Drying the moringa leaf and convert into powder, and there are some companies who are, so for that, because moringa leaf, if you export, it will become pale yellow and it will lose all the moisture. So that also has been done actually in the same site. So this is some of the calculations where they use wood actually. This very specific presentation mainly to intend to from the wood they are changed to the heat pump. There is a refrigeration. It's a heat pump equipment. It's a kind of a reverse refrigeration cycle. So using a heat pump. So what is the advantage? We can reduce using of trees and at all, and we can use a heat pump. And heat pump will give a very uniform drying characteristics, maintain color and nutrition value as well as texture. Okay, this is the drying curve. Okay, this is very important on this drying and the preservation based on drying. Every product when you are subject to drying, it will slowly, the moisture will that of drying. Sun drying, you put it on sun, but what it done is it will remove the moisture, it will go off, but the color will change, which customer won't like. So so without sun, how to dry faster? If you keep it as it is open, it will not dry. It take long time. By the time water activity, it will contaminate and it will decompose also. So that's why you dry it less than 24 hours. You harvest. If you want to dry it, you have to dry it less than 24 hours. So for that you have to do. Every produce horticulture crop have a different drying curve actually. We call drying curve. This is a drying time. As the drying time, we increase drying time, the moisture will come down. It's a dry based moisture. Okay, dry based. The moisture in kilogram, there is a moisture at kilogram per hour. Initially, the drying will be very slow, and at one point, suddenly there will be a lot of moisture. Once the water and all the water, bone moisture, and the surface moisture will go initially. Once the typical point will come, at that time the bone moisture also will release actually. Means I can say it is like what do you call diffuse. Okay, the first stage will be moisture on the surface of the produce will evaporate, but the moisture internally in the produce will diffuse actually. The peak moisture, so you can see fifth hour the moisture kilogram per hour. 50 per hour. And once the diffusion starts, then slowly the moisture will come down. But within 24 hours, if you can able to dry it and keep it, you protect the color, you protect the to some extent texture, nutrition value, everything, and that's how the dry will happen. Actually, curve generated with different point trials for this cardamom. Okay, warm up and constant. So there are different type of initial drying period, constant drying period, then very target moisture drying period actually. These are falling late. So slowly twisted warm up, steep drying, then flat drying. Like that, every product have the same trend actually. If you can automate your drying machine, then you can do any with characteristic of any fruit or vegetables. Then you can actually make kind of business case, and you can make a machine out of it, and you can dry appropriately where the customer likes the product. So that way you can do an experiment. You can. Yeah. So these are kind of a typical how the substance made. They made a chamber with a heat pump, recirculate using a PLC, programmable logic controller, which can track, which can monitor the relative humidity, the airflow rate, the temperature, gradual increase of temperature, initial temperature range, and sudden falling period of drying rate, and last slow drying. All the three stages you will monitor. That's kind of an algorithm that will set actually. So you'll get a very, very green color, and the black color you are seeing is not black. That is kind of what do you call that typical edge of the fruit. You'll have that kind of flower, that flower leaf actually. So once you dry it, it will go off actually. So this is how the carbon dioxide emission also, because they are reducing the wood actually. Purely they are using electricity. That's why. This is a heat pump using the cardamom. So you can see the wood dryer. In the wood dryer, how it is inconsistent color with which is lower price or even some quality issue. It's kind of a manual wood briquette and all. Lot of smoke. The smoke also will not. But you can see here, it's very, very uniform green, and actually for this is important. So we're talking about food preservation. The shelf life will be very, very high actually. So there's some of the business case, OPEX and OPEX, how much using a self-use model 1.5, you can reduce the CO2 of 3. This particular kind of, they even said last year, they talked about how much amount of CO2 they are reduction per year. And the events acknowledged project, okay, which is good for us. So I have actually for today on these 3 case studies. Actually, hello.
Yes, sir.
Hello, sir.
Yes, sir. Yes, sir. Yeah. So participants, any questions? And Dr. Prasad has informed that as per FSSAI, banana ripening, 100 to 200 ppm ethylene is recommended for artificial ripening.
Yeah. Okay.
Okay. That is
okay.
one information. Yeah.
Yeah.
Sir, I have some questions about that. So traditionally, we are using vapor compression refrigeration system for
yes, sir.
Yeah, for freezing, for cooling. So nowadays, with respect to the alternative to vapor compression, in anything is commercialized, sir, as of now, because other alternative techniques we are keep on doing research. In some places only we are able to see some alternative methods such as vapor absorption or adsorption or magnetic refrigeration systems, all these things.
Okay.
So anything is been tried, or any idea on that, sir?
Okay. No, we see still vapor compression is highly efficient. You can get the COP anything not less than 3.5, right? See in our drying, the drying, what we are doing, the drying, the efficiency, starting efficiency is 4.5. It's a heat pump, right? And ending efficiency around 3. So average we are getting 3.5 to 3.8 COP. But you see the vapor compression, apart from vapor compression, we are not even crossing COP more than 2, even till today. You can say magnetic reflection, baroque calorimetry, all these things, it will go less than 1.5 COP. So that's why we couldn't get a breakthrough still today.
Okay. So one more question Vipin has asked. Sir, heat pump for drying cardamom run electrically. electricity
Yes.
like that. Yeah.
No. Yes. Through electricity only. Yes.
So actually, what he is trying to ask is, instead of that, we can use directly electric heater like that. He is trying to ask.
Okay.
Is
Okay.
the
Electric
question?
heater. Electric
ஒரு இடத்துல
heater.
நிம்மதியா இருக்க
If,
முடியாது.
if you use one. Okay.
ஒரு இடத்துல நிம்மதியா
If you
இருக்க முடியாது.
use.
ஏன்
If you use
1
1
second, sir. 1
kilowatt of
second, sir.
electric heater.
காலு
If you use
Joel,
1
please
kilowatt of.
mute that participant, please. 1 second, sir, please.
Yeah.
Prakash
Okay,
GP
I'll
is
tell
mute. Yeah. Yes, sir, you can.
If you use electric heater, I'll tell you this: 1 kilowatt of electric heater with efficiency of 90%, you'll get heating output 0.9 kilowatt of heating output. Okay, hot air heating output. But if you use 1 kilowatt of electric energy for the heat pump, you will get 3 kilowatt of heat. So it is
Yes.
3 to 3.5 times more efficient than the electric heater. Otherwise, what will happen? Okay, what will happen is you will end up in, see, today I'm using for a 500 kilogram of cardamom, I'm using only 10 kilowatt of electricity. Kilowatt hour, 10 kilowatt. I can say 10 kilowatt instantaneous energy. But if I use electric heater, it will be 35 kilowatt. I use electric heater. It is impossible.
Yes.
Very energy
So,
intensive. That's why.
whatever the electricity you are using, that will be converted to heat. If you use a electric heater, but if you use a heat pump, that will be multiplied by either 4 or 5.
Yeah,
In
exactly.
sense we can explain. Yeah.
Yes, correct.
Yeah. Sir, coming back to this alternative to vapor compression. So even though COP is less, we can operate it with other forms of low grade energies. Even then, even then COP is less. This advantage is there, but still, why this is not coming up in the market? So one reason I understood that it is COP, and also the high cost. But for high capacity application, is it possible to go for alternative methods, or
Which
still we want
application?
to follow only?
Which application?
Maybe for high capacity application, maybe for 100 ton of cold storage systems, or 50 ton of cold storage
No,
system.
any
We can try with
any tonnages. Ultimately,
okay.
how much amount time energy spending? What is the cost is important, right?
Okay. Yeah.
Okay, it can be small or it can be high. End of the day,
Yeah.
like how much I am, what is my input and what is my output? So that
Okay.
matters a lot, right? And what is the money involved in that?
Yeah. Investment cost is huge in the case of
Exactly.
alternative method.
Exactly. You are right.
Yes. Okay, participants, you can feel free to ask questions. Here, this is the mixed group, sir. Here, mechanical, biotechnology, pharmaceutical, all mixed group is there. And yeah, I think mechanical, definitely this is a very good information, because a lot of things you have said about these case studies. I think, yeah.
Freeze drying.
Yeah.
Freeze drying also one of the good technology for preservation. That's why I selected that actually.
Yes, sir. Yeah, if no more question, we can come to the conclusions that either Joel or Ravi is there.
Yes, sir. Right. Yes, sir.
Yes. You can thank sir and you conclude the session, please.
Sir, thank you for giving this wonderful lecture on case studies of successful food preservation and enterprises. Sir has dived deep into real-world examples and has given us valuable perspectives on innovative preservation techniques, sustainability in food processing, and the critical role of technology in extending shelf life while maintaining the food quality. The case highlighted today have shown us that the success in food preservation is not just about technical expertise, but also understanding market needs, regulatory compliance, and continuous improvement. As we move forward, let us take the inspiration from these enterprises and apply this learning to drive innovation and efficiency in our own ventures. Once again, our sincere thanks to Mr. Jayaprakash Guruswamy for sharing his expertise and to all our participants for your engagement. We look forward to more such knowledge sharing sessions in the future. Thank you once again, sir.
Thank you. It's my pleasure, Mr. Dr. Mariappan and all the participants and all the professors here. Thank you very much, and I look forward also.
Yes, sir. Thank you, sir. We will keep in
Involved.
touch, and I will disturb you, sir, more hereafter because
Yeah,
a
yeah.
lot of line of
You are
things
most
are there
welcome.
coming.
Yeah.
Yeah, yes, sir. Yes, sir.
Yeah.
Thank you so much,
Thank
sir.
you very much, Dr.
Yeah,
Mariappan.
thank you.
Yeah, thank you.
Thank you. Thank you.
Bye. Yeah.
So please stay. I will just contact the next speaker. If he is free, we will start the session immediately, or we have to wait up to 7:30. Let me know that, please. Joel, Ravi,
Yes, sir. Yes,
yeah,
sir.
he is joining now. We will start the session now. So some of the questions have been asked here. How does the food preservation help in maintaining the nutritional value? And each and every presentation has some effect on the nutritional content. The thing is, with modern technology, we reduce the loss of nutritional value. So next speaker is expert on that. Definitely, you will get answer for this. We'll post the question again.
Hello, sir.
Yes, sir. Good evening, sir.
Yeah. Good evening, sir. So we can hear.
Yes, sir. Thank you, sir. Thank you for coming and with your busy schedule today is our convocation. Yeah, in between conversation, he came here. Thank you. Thank you so much. We'll start the session, sir. Joel or Arun, welcome, sir.
Yes, sir.
Yeah, we'll
Okay.
start.
Good evening, sir. We welcome you for this Atal FDP workshop. Our next speaker is Dr. R. Jagan Mohan. He's a distinguished professor and dean at the National Institute of Food Technology, Entrepreneurship and Management, Tanjavur, specializing in food science and nutrition. With over 34 years of research and teaching experience in grain processing, he has significantly contributed to advancement in rice, pulse, and millet processing. Dr. Jagan Mohan earned his PhD in food science from Tamil Nadu Agricultural University. Throughout his career, he has led numerous projects, including the development of low friction hullers and rice dejammers, and has focused on the novel value addition of milling byproducts through extrusion cooking. He has published more than 75 articles in national and international journals and authored book chapters on pulse food quality and nutraceutical properties. His research interest encompasses food product development, extruded products, low glycemic foods, and ingredient quality analysis. Dr. Jagan Mohan has also been instrumental in establishing NABL accredited food analysis laboratories and food processing business incubation centers, contributing to skill development and knowledge dissemination in the food processing sector. We welcome you, sir. The session is yours.
Hello.
Yes, sir. Sir,
Sir, I'm
start,
not
sir.
getting. Okay. Shall we? Okay, sir.
You didn't. That is, we have done the welcome. You are not able to hear, sir. Hello. Hello.
No. Yeah, but are you getting my PPT for this?
Yeah, PPT. Yeah, it's visible, sir. Yes, sir. Yes, sir. Visible, sir. So you can go to presentation mode,
Okay,
sir.
sir.
Please.
Okay, sir. That's what I just
Yes, sir.
want.
Yes, sir.
Yeah,
Yes, sir.
okay. So, very good evening to one and all. I think in the email, I want to do that sustainable and resilient security.
You please make a slideshow mode, sir, for PPT.
Are you getting my thing, sir?
Yes, sir. Actually, you just go to presentation mode, sir. It is not in presentation mode. Just you click the presentation mode, sir, or F5. Professor, are you able to hear me, sir?
So, okay. So, In addition to direct economic losses, there is also result in the poor management of.
Screen is not visible, sir.
Screen not visible.
Not visible, sir.
Is it visible?
No, sir, it is
Okay,
not
there is
visible, sir.
something it is coming out. Wait. Sir, are
Yes, sir,
you
it's visible, sir. Yes, sir, it's
visible?
visible now, sir.
So I slideshow mode. Okay, sir. So shall I go to this?
Yes, bro. Yes. Yeah, I can.
Turn on the presentation mode, sir.
So I think now it is okay, sir.
Yes, bro, sir. You can go ahead, please.
Okay, sir. So this the main from different is fruits and vegetables. The main one, and one is this. So if you see the major sustainable development goals is among there are 17 sustainable goals. Out of that, if you see sustainable development goal 2, 11 and 12 are these mainly concentrating on the making up of the fruits and vegetables into different processing or the food sector into a different processing condition. So this is one of the statement from Super Ludhiana's survey on the post-harvest losses of different crops. If you see this average food production versus food wastage, it is around 18% fruits and vegetables are wasted, and oilseeds 6% of the oilseeds are wasted, and in pulses it is around 6%. Cereals altogether is 6%. In the milk it is 0.8% only. So the remaining things are around within the controllable limit. Even though that is thing we want to go for text based fast, we can say it is can be directly divided into two things. In the past, it is smoking, dehydration, curing, freezing, homic or aseptic processing, irradiation, super chilling, microwaves, and pasteurization are the part of things. And then slowly, the other way around is magnetic fields, pulse technology, and pressure sterilization, combined irradiation, and microwave sterilization, antimicrobial thing, which is natural or normal fruits and vegetables. So there is a safer storage stability for each crop and each things. And salting and curing, it's a traditional, very old techniques and traditional things where there is an reduction in the water activity because of the salt, adding salt, sodium chloride in the food systems, and preserving it in a longer time. A lot of technologies have evolved, but now it is the major thing is that we want to reduce the salt content, and we have to have the same impact on the food products for the preservation. So next, natural bacteria, yeast, or mold converts sugars and starches into acids and alcohols or gases, enhancing flavor and that is the like we can say that the cradle of fermented food products. If you see rice, wine, or any component
Sir,
of
excuse me, sir.
the food as
Sir,
being
excuse me,
preserved.
sir.
Yeah.
Sir, excuse me. Your
Slide is
PPT
not
Yeah,
is
please
not
tell me.
visible, sir.
visible, sir. Not visible, sir. Your PPT is not visible.
Oh, okay. Wait, system right.
Okay, bro, sir, you take your own time, no problem.
Sir, I will check with the other system.
Yes, sir. No problem, sir.
Sir, it's now visible, sir.
Yes, sir. Now it is visible, sir. Yes, sir.
Cross this one. So mainly third of the food waste consists of 82.5% of 51% of carbon and 7.2% of hydrogen and 38% of this sort oxygen and 2.8% nitrogen and 0.7% sulfur. So according to the so what is the Sustainable Development Goal and the agenda that is placed by the United Nations is saying that we have to contradictorily reduce that fruits and vegetables.
Sir, your voice is not audible, sir.
Yeah, sir.
Voice is not audible, sir.
Voice is not audible. Okay.
How it's audible, sir?
Okay. It's okay? No?
Maybe you can switch off your video, sir, so that you will get some
Yeah,
bandwidth.
the signal maybe.
Yes, sir. Yes, sir.
All, rice, take if you see the rice is a major consuming material in our Indian population, and primary products are mainly rice, dehusked rice, raw rice, and dehusked unpolished or semi-polished rice, parboiled rice, whole grains, and these never needed too much of a preservation. But when when we harvest the grain, 18%. So where it has to be reduced to 14% for the safer storage. So here there is a freezing and sometimes the harvesting and the rainy season coincides, which is creating a bigger problem in our delta region, especially in the delta region. So that there is a loss in the paddy. 100 kg of paddy, and out of that 11
Your voice is not audible for some time, sir. It's audible and not audible. Like this.
Now it's okay.
Okay, now, sir.
Okay, so that is a weight of high moisture paddy. Because of the high moisture paddy,
Hello, sir.
they have to. Hello.
It's more clear, sir.
It's more clear.
It's clear now, sir.
Okay. Moisture imbibition to the grains, and then we have to make it as
I
a very
think
good.
your mic is very far away from you, sir. It's very less, sir.
1 minute. Is it okay now?
Sir, it's clear now, sir.
Okay. Grain. So as quick as possible, what are the products that can be generated or that can be developed using trading that? So we have come up a lot of integral products like conventional products with major thing is that puff rice or something like that, and then non-conventional products of flaked rice, puffed
weaning and malting and pasta products, baked products and extruded products, and health and functional foods and traditional. So rice, when you see the whole cooked grain, raw and modified rice and products. If you see, we can three categories we can do that. And in the modified rice, any other product. So expanded products are major things. Fermented products, bakery products. What are the rice and how it has to be consumed? What are the things? So we most of the people in the grain and less extension the grit. It should not become a bold grains when cooked it, and more swelling should not be there. So what are the characteristics are the major imparting things are that pastiness, soft, hard, and flaky, and moist, dry quality, and suitability for cold rice and retrograde. What do you mean? We just cold rice means it should be suitable for the next day also. So when you consider most of the poor people are those people who retain the cooked rice for the next day. So that is a maintain the cooked grains integrity should be maintained. So these are some of the characteristics which we are looking in for the rice and retrogradation of heat. It retains its shape and elongation and softness. All retrogradation characteristics is important one. When you chew it, when you eat it, the chewiness should not be there. So like that, so there are a lot of impact on this one. So monetary value of rice and pulse milling byproducts. Out of this, there are a lot of byproducts are coming out. So one of the major things byproducts having around 20,000 crores per year is we are getting in. So why rice value addition we are looking in for the major thing is this rice milling and polishing that converts brown rice into white rice. So 67 when you are polishing, you are losing around 67% of the vitamin B3, 80% of the vitamin B1, and 90% of the vitamin B6, half of the magnesium and half of the phosphorus. So 80% of the alternate utilization the food system. So these rice brand, the byproducts have a very high quality of directly it has impact on the gut health. So we have to slightly modify to suitability of the whole population. So in and around the Delta district, we have around 185 rice mills. Different levels are traditional. So each different rice mills have a different output of for a survey on the whole of the system. We are observing that up to 30 to 38% of the pulse byproducts we are obtaining, which is our high proteinaceous material and high quality. When we grade it in a proper way, we can get a high quality proteinaceous material, which can be a health benefit for different things. So one of the major things which we made out of that is like nutri-rich products, gluten-free bakery products, which was incorporated the rice brand, which was sieved and particular components, particular level of components was taken and extracted, and these components were incorporated into different food products. So out of this, there are a lot of food products that emerged from this health benefit. So if you see this, what are the products that byproducts of their industries, food industry?
Professor, sorry to bother you.
Ah.
Professor, your mic is some loose connection or some wire is hanging. Can you check it? Because voice is going up and then it is coming down.
Okay. So now it is okay? Is it okay?
Sir. Any loose connection is there or any wire is hanging? Can you check from your side, sir? Please.
Okay, now we can.
Yes,
Hello?
Professor. Yeah, yes, Professor. Please.
Yeah. So this
Went down.
now it's okay.
Yeah, it is going down and then increasing, down and increasing.
Internet problem is there.
Network issue, sir.
Any network issue there.
Okay, sir. Then you can go ahead, sir. No problem. No problem. It's
Okay.
fine.
One minute. Sir. Yeah, I'm in a meeting. I'll call you back. So this is a second and third generation snack foods. So the meaning of the second and third generation snack foods are that earlier it was the rice and converted into flakes or puffed is the first generation, and then the second generation the flour is mixed. Another pelletizing with third generation where you can convert it to a different product, or you can put it in a different format in a ready to eat form or in a in pack cooking self-generated shapes. So it will be plain shape only, but it will be self-generating one. And this is a traditional rice cookies and pasta, which are that karb kauni. We observe that high antioxidant and protein content and high level of energy and easy digestible material, and which is having an high concentration of vitamin E and carotene and calcium, other impacts. So these are the rice-based beverages and rice milk and ice creams and malted foods. So malted foods are both geriatric and then pediatric foods. So we can convert that into different formats in different drying condition and roasting condition, making it more suitable for the aged as well as the younger generation. The Nutri bars now. Food with 50 grams, it should give around 300 to 400 calories. Like that, it is easy for the defense people to carry on the required nutrition in a smaller quantity with lesser weight. So the rice starch is absorption and oil absorption characteristics, water absorption characteristics, and making into a different format and easy digestible, and or you can make it as a film. One of the based on one of the sweets that is from the Andhra. So these are the few technologies that have been developed in our institute. So once again, I just want to see what are the how this waste and can be converted into different value-added products. So it is improving the value chain of the crop up to the last mile. So these are the products which have been developed from our institute: muffins, rice bran, cookies, and kurkure type of a product, and the rice bran pasta. So this is one of the extruders, single screw extruder, which is having an impact. Only the expansion will be there, or we can use it for the modification of the starches. Plenty of work can be done on this, and not only with the rice and pulses, but also all other products which can be used for the film making, biofilm making also. So this is another type of extruder where this is a twin screw extruder and segmented screws, where you can change this screws length. You can change the screw length or the mixing property or the extrusion or giving a compression. All these properties can be changed within the segmented screw. Here we have done with the pulse analog. So grains, when we see this rice and the pulses waste are coming out, we are using these two things to make it as a reorienting or to ready to eat product of changes in the same machine with some changes in the operational conditions. We can make it as an excellent product for different end users. So another major step you can see this how say that nutrient enriched byproducts can be converted into value added product. The slides are moving. Okay. So when we do certain products, we have to optimize the flour can be used for preparing cookies, and different flour can be used for different end uses like idli in the South Indian food, and in flour flat chapatis in the North Indian food. So this is supplemented for the malnourished and severely malnourished children, can be given with an high protein materials and high anti-nutrient factors. So that anti-nutrition factors can be reduced by pre-treating with the with some of the technologies. So this is a potato fines how we prepared with different products by products. So one of the thing is that the outcome of the project was like this. We have able to produce some different category of and paste and seed oil as been incorporated into different sheets. We can make it as a baked products like chips, twists, and these are the products. Ingredients were product was designed from. So next, the major thing which I have dealt with the project is jackfruit value chain. So jackfruit is a very prominent crop as far as in India is concerned. So near about 2,000 crores of jackfruit is wasted throughout India in every year. And when you see this production of the jackfruit, there are a lot of jackfruit production in and around Tamil Nadu and all over India. So the major thing and how to harvest it and what
given a clear-cut idea about how to handle this and how to count without jackfruit as purple 20 to 30% and seeds is 12 to 15%. The rind and strand or core is around it all makes up to 50% of the whole weight. Say for example, if a farmer carries 10 kgs of that far to market, or what we can do is an alternative. So one of the alternate technique what we have prepared and suggested was that we can process the jackfruits in the farm level, and there are different sizes and different things. The difficulty is that peeling and removing all the processing for the harvested jackfruit. And these jackfruit components were made into a flour, which can be converted into different value-added products. So one of the such value-added products are this one. So if you see here, each byproduct and the product are converted into different formats, and we have suggested for different end products. So for example, we can go for a bakery and confectionery products, or composite flour can be made, which can be used for the waffle making, ice cream cones and edible plates, and extruded products, pasta and noodles. These are the common utilization where you are converting kgs what you are 25 kgs converted to different end uses like edible plates and other things. So this is the concept what we have given, and was more successful in the marketing strategy. And major feed. This can be converted into valuable products for the food ingredients applications. So food ingredients applications is the major thing is the pectin, which is used for the many of the jams and jellies and making all the products. So to extract the pectin and extraction of pectin compared to the normal technique, because of the binding characteristics of the major that peel jackfruit peels composition, and the structural is broken down, and we can able to extract high quantity of pectin, and that pectin can be used for making a lot of value added products for the jams and jellies and some other value added products. So, so another bitter gourd, actually the seed is having a high quality nutraceutical oil. So to extract that, we have done some of the techniques, and then we have extracted using the ultrasonication and hydrodynamic degrading that oil, and then using for different end users. So thank you. So some internet issues are there here.
Sir, yeah.
I'm not able to.
Yeah. Am I audible, Professor?
Yeah, yes, sir.
Okay. Even though voice is breaking, but informations are coming in the slide. There are some couple of questions. It is not related to exactly your presentation. One of the question is, how does the food preservation help in maintaining nutritional values? Any answer from you, Professor?
Observation?
How does food preservation help in maintaining nutritional values? And related to that, one more question is also there. Each and every preservation have some effect on nutritional content. The thing is, with the modern technologies, we reduce loss of nutritional value. Like that, some general assumption is there. How we can address to that, Professor?
The major thing, as I said, near about 1/3 of the whole population is going without food.
Yes.
So that is the thing.
Can you repeat because voice is not audible? Please repeat.
1 minute. So the production and the wastage that is created in India alone, the fruits and vegetables alone, I'm telling, it is equivalent to the production of UK. So you can imagine is wasted here in annually. So whether that we can satisfy that population. So how to prevent? Say,
Exactly.
the thing is that at least we can give that.
Yeah. The food chain we can maintain sustainability. We can maintain.
And
That is the major goal.
A major thing is that when we are using the preservative techniques, the preservation technique, which is, say, for example, when we started eating the food, we had only 0% salt. But now, salt and fat are more in our industrialization and other things, which is causing more of an disease, non-communicable disease rate is high. Now we want to go back, but we cannot go back in that. But we have to find a technology where we have to sustain this taste, flavor, everything without impacting on the health condition. So in that case, when we are using a salt, what is the alternate salt, or what is the level of salt it has to be used for the preservation of different food items, and how it has to be recommended to take that. So usually when we are starting, when now the pediatricians are recommending in such a way that don't introduce salt or sugar or any of the taste without you to give a bland taste of food for the population. They sustain for next 3 to 4 years. After that, you can introduce some of the things which will have a very high impact on their health, for improving their health. If you are doing right from the starting, if you are once the weaning foods are started, if you add some salt and other things, the people are more salt, they won't be tasty. So first thing is that pediatricians are recommending now, they're recommending to reduce the salt, which will be the brain stimulant. When we test for the sensory quality of the food, there are certain signals are coming out of the brains, which is showing here more salt addiction. So the one thing, the preservation will be surely for giving a nutritious food. We are all are aiming for giving a nutritious food in such a way that the newer emerging technologies like non-thermal techniques are there. You are killing only the microorganism without much of a treatment, without the chemical use. So once the chemical use interaction between the nutrient between the nutrient and between the non-nutrient components, which is having an impact on our health. So we are evolve a newer technique using a combination of different treatments like ultrasonication, and we can use salt preservation with a minimum rate is higher, and the quantum of salt used for the imbibition is lesser, but the preventive effect is more on the food. These are some of the techniques which we are evolving on different aspects. Anything else, sir?
Thank you, Professor. Yeah, nice answer. Because so we have to give food to everyone. In that aspect, the nutritional aspect is come in the second importance only. So that is what we understood.
Excuse
Yeah,
me, sir. I am Gurumurthy.
Yes, sir.
Can I have some discussion with the professor, sir?
Yes, very well. Yes.
Sir, good evening, Professor Jarmohan, sir.
Tell me, sir.
How are you, sir? I am Gurumurthy from Chennai, Saram IST.
Okay, sir. Okay, sir.
That's what, sir. Thank you very much. First of all, really we grateful to you. Instead of even in spite of your busy schedule and other convocation, board of studies meeting with in FTM, though all those things are there, you have spared your time and you really presented well actually. Maybe some internet issues was there, but anyway, your PPT material was really wonderful, sir. A lot of information you could able to grasp it. I have some little need some clarification. Mainly, you mentioned that the hydrodynamic processing. So, what are the type of hydrodynamic processing was employed for doing that particular product? And also regarding the gluten-free product and karpu gauni based cake you made, you mentioned that. So how the texture was maintained? Because pretty well we know that texture of these particular products are very much important. So these are all the challenges, how you have made. So those things I wanted to get clarified from you, sir. Thank you, sir. Thank you.
Sir, always rice and example, our traditional process of adirasam. We have used in Tamil Nadu, we call it as adirasam, and what we do is deep fat frying. The texture quality is good when we are making it in a deep fat frying, but make it in a steam baking, it's similar to that. So we are reducing the oil as well as we are just fermenting the rice flour with jaggery and then making it as a soft and more texturally acceptable. So
Gurumurthy sir,
Yes, sir.
you have any more conversation?
Yeah, only one small request, sir. Is it possible for sharing the PowerPoint presentation, sir, so that
yes,
we
sir.
get some, please, sir. Please, sir. So there is a request from my side, sir.
I can share you, but there are some changes in that font or something because of the
No
display.
issue, sir. No issue, sir.
So you can share it to me, sir. I will share it to the group if you are not.
Okay, sir. Okay.
Thank you, sir. Thank you very much, sir, for your valuable time and valuable information, sir. We'll keep
Thank
in
you,
touch
sir.
with you, sir. We'll keep in touch with you.
Okay. Thank you, sir. Thank you.
Thank you. Thank you.
Thank you, Professor. Yeah, because I have disturbed a lot. That is.
No problem.
Yeah. So if there is no further question, we'll come to the end of the session.
Okay, sir. Thank you.
I request my scholar to give vote of thanks to you, sir.
On behalf of everyone present, I would like to extend our heartfelt gratitude to Dr. Jaganmohan for his enlightening section on fundamentals of food preservation techniques. His expertise and deep insights into preservation methods, emerging technologies, and the role in ensuring food safety and longevity have provided us with a strong foundation in this critical area of food science. A special thanks to Dr. Jagan Mohan for taking the time to share his wisdom with us, and to all participants for their enthusiasm and engagement. We look forward to future interaction that will continue to enhance our understanding of food science and technology. Thank you for all.
Thank you, Professor.
Thank you, Maripan, sir.
Yeah, thank you. So all participants, thanks for patiently listening. The internet, we are not having any control over there. So please bear with us. Sometime it will happen. So sorry for that.
Thank you, sir. Thank you so much.
Thank you so much. We'll meet tomorrow by 6 o'clock.
Yeah, sure, sir.
Thank
Yeah,
you.
sure, sir.
Thank you all. Thank you all.
Thank you, sir.
So much for your feedback. I'll end the meeting now. Stop record now.